Hello everyone, I'm Sinchana from CSC branch. Today I'm here to present a subject operating system in that topic thrashing. Firstly, introduction to thrashing. Thrashing is a phenomenon that occurs in a computer systems when a excessive paging or swapping takes place. It leads to decrease in the system performance and can cause the system to become a unresponsive. Thrashing usually occurs when the demand for memory exceeds to available physical memory. Thrashing is an operating system refers to a scenario where the system is spending more time swapping data between the main memory and disk than actually executing tasks. However, there are no inherent advantages to thrashing. Thrashing is a determinantal to the system performance and can significantly degrade overall system efficiency. It leads to increased response times, poor throughput, and can ultimately result in a system instability or failure. Therefore, it is considered a problem that needs to be addressed rather than an advantageous feature. Causes of a thrashing. Insufficient physical memory. When the system lacks enough physical memory to handle their workload, it resorts to excessive paging and swapping. Poor memory management. Insufficient memory allocation and deallocation algorithm can contribute to thrashing. Overloaded system. Running too many processes simultaneously can also lead to thrashing, as each process competes for limited memory resources. Symptoms of thrashing. High CPU utilization. Thrashing causes the CPU to spend an excessive amount of time on memory operation, resulting in increased CPU utilization, contest disk activity. Frequent disk reads and writes due to excessive paging and swapping, indicated thrashing. Unresponsiveness. This system becomes slow and unresponsiveness as it spends more time on memory management rather than executing user tasks. Detection of thrashing. Monitoring a page fault rate. An abnormally high rate page faults indicates the thrashing. CPU utilization. Consistently high CPU utilization with a low performance can be sign of thrashing. Disk input output operations. Monitoring disk input output operations can help identify excessive paging or swapping. Effects of thrashing. Decreased system performance. Thrashing leads to a significant decrease in the system performance and responsiveness. Increased response time. As the system spends more time on memory management, the response time for user requests increases. Increased disk wear and tear. Frequent disk reads and writes during thrashing can cause an increased wear and tear on the disk. Prevention of thrashing. Sufficient physical memory ensuring that the system has enough physical memory to handle the workload can prevent a thrashing. Efficient memory management algorithms. Efficient memory algorithm using a optimal memory allocation and deallocation algorithms can reduce the analysis of the thrashing. Load balancing, distributing the workload evenly across a multiple system, can prevent any single system from becoming overloaded. And last, advantages and disadvantages of thrashing. Firstly, advantages of thrashing. There is no inherent advantages to thrashing in an operating system. Thrashing is a detrimental condition that occurs when the system is overwhelmed with too many processes competing for the limiting resources. It leads to a degraded performance, increase overhead, poor resource utilization, and system instability. Therefore, it is considered a problem that needs to be addressed rather than the desirable future with advantages. Sufficient physical memory, mitigation of thrashing. Increasing a physical memory, adding more RAM to the system can alleviate a thrashing by providing a more space for the process. Tuning memory management parameters. Adjusting a parameter such as the page size or swapping thresholds can help mitigate thrashing. Prioritizing a processes. Giving a high priority to the critical process can help ensure they have enough memory resource to function properly. Case study thrashing in an operating system. And few disadvantages of the thrashing or the degraded performance, increases overhead, poor resource utilization, system instability, difficulty in diagnosis. Over determinable conditions that undetermines the system performance, resource utilization, and stability. It is crucial for system administrators to the monitor system. Resource effectively implement a optimizing resource allocation for adjusting a workload priorities. Case study of the thrashing in the operating systems. In operating systems, thrashing can occur where the system is overloaded with a process that requires a more memory than available. This can lead to excessive paging or swapping, resulting in a poor system performance. Efficient memory management algorithms such as the demand paging and page replacement policies can help to mitigate the thrashing. Case study. Thrashing in database systems. In database system, thrashing can occur when the working set of data exceeds the available memory. This leads to the frequent disk reads and writing, causes a significant decrease in query performance. Implementing a proper indexing query optimization can catching a mechanisms can help prevent thrashing in database systems. Real world example, web server thrashing. Web servers can experience thrashing when they can receive a sudden surge in traffic that exceeds their capacity. This can result in excessive disk input-output operations, increased response time and responsiveness. Scaling this infrastructure by adding more servers or implementing a load balancing techniques can help mitigate web server thrashing. Let us conclude this topic. Thrashing is a phenomenon that occurs when excessive paging or swapping takes place in a computer system. It leads to a decreased system performance, increased response time, and unresponsiveness. Preventing a thrashing through the sufficient physical memory, efficient memory management, and load balancing technique is crucial for the optimal system performance. Thank you.